Hi everyone, my name is Ivan Patrick Di Salidosa and I'm about to report to you the radio waves and its propagation. Did you ever wonder on how the signals and waves revolve around us? Usually, it is all around us but we just didn't notice it. So today, we are going to tackle radiation, waves, how do they propagate, and most importantly, how they travel as a source in different areas. And here is why we should know more about radio waves and radiation. First off, radiation has two categories, which is the electromagnetic radiation that relates with James Clerk Maxwell and nuclear radiation which also relates to Marie Curie. In electromagnetic waves, it was well known for James Clerk Maxwell, who is a Scottish physicist, and he is best known for combining the fields of electricity and magnetism to create a theory of the electromagnetic field. At the age of 14 years old, he published his first academic paper in the Proceedings of the Royal Society of Edinburgh and later to the University of Edinburgh and the University of Cambridge. Based on his theory, electromagnetic radiation is a pure energy that consists of electrical and electromagnetic waves. They are also capable of oscillating through space, uh, which is whenever these waves travel faster, they are scaling up of energy. Here is an example of electromagnetic spectrum wavelength range, in which range from lower end to the higher end. On the lower end, these are the radio, microwaves, infrared, and visible light. And on the higher end, ultraviolet, X-rays, and gamma rays. On the other hand, let's talk about Marie Curie. She was regarded as the woman who opened the nuclear age. She also discovered the radium, and radioactivity was her rather baby. Furthermore, nuclear radiation originated in the atomic nucleus and comes from the natural source called radon. A phenomenon called nu- strong nuclear force keeps the nucleus intact with each other. But not all of them are hazardous. In fact, ionizing radiation is a type of energy released by atoms in the form of electromagnetic waves or particles. For the next part, propagation of waves involve the transmission of information from one location to the another. For instance, electromagnetic wave is created by a local disturbance in the electric and magnetic fields. From its origin, the wave will propagate outwards in all directions. If the medium in which it is propagating, like say air for example, is the same everywhere, the wave will spread out uniformly in all directions, and in its direction will always be perpendicular to the wavefront. Now let's move on to the radio waves. So what are its optical properties? Radio waves are also like light waves, in which they can be reflected, refracted, and interfering. First is the reflection. When a radio wave encounters a change in medium, some or all of it may propagate into the new medium, and the remainder is reflected. The part that it enters the new medium, it is called the transmitted wave, and the other is the reflected wave. When a reflection occurs, it can be seen that the original wave can be called as the incident ray, and the movement is the same for the incident ray for the reflected ray. Second is the refraction. As you can see in the picture, Refraction occurs between the boundary of two media. In that boundary, some of the electromagnetic waves will be reflected and some will enter the new medium, and it can be shown as refracted. As I have said, the radio waves are also like light waves. They also follow a basic law called Snell's law, which expressed in its refractive index, letter N, and the angle of incidence, sine theta. Third one is the diffraction. Whenever radio waves goes diffracting, it means that a signal from transmitter may be received from a transmitter even though it may be shaded by a large object between them. Diffraction can be understood in Huygens principle, where it states that all points from a wavefront in a vacuum or transparent medium may be regarded as new sources of wavelength that expands in every direction at a rate depending on their velocities. As based on the picture, for frequency low signals, a mountain range may provide a sufficiently sharp edge. It is also found out that low frequency signals diffract more markedly than the higher frequency. It is for this reason that signals on the long waveband are able to provide coverage even in hilly or mountainous terrain, where signals at very high frequency and higher would not. Last one is the interference. It is a phenomenon that occurs when two waves meet while traveling along the same medium to form a resultant wave of greater, lower, or the same amplitude. Whereas you can see in the picture, just like in a bar, full of sounds, and there are times or a place you can hear your voice, but sometimes you can hear them. With this, once the radio waves collide with each other, there is a tendency that there are disturbance from what you hear, or it is called rather as interfering. For the last one, radio wave propagation has the light of sight propagation, ground wave propagation, and sky wave propagation. The line of sight propagation has waves travels in a direct path from the source to the receiver. The rays or waves may be diffracted, refracted, reflected, or absorbed by the atmosphere, and obstructions with material and generally cannot travel over the horizon or behind obstacles. In a ground wave propagation, from the term ground, they propagate from the ground over the Earth's surface. Whether it is in the medium or low frequency, it is mainly used for transmission between the Earth's surface and the ionosphere that can reach up to 2 MHz. Lastly is the skywave propagation, which transmits back and forth from the transmitter to the ionosphere, that can be received by many transmitters. It transmits up to the ionosphere as an ionized layer of the Earth, making it suitable for a skywave propagation. Those who use this propagation are broadcasting and telecommunications. For our summary, electromagnetic radiation propagates in space as well as in other material medium. Nuclear radiation consists of ionizing and non-ionizing radiation, in which is a type of energy released by atoms in the form of electromagnetic waves or particles. The propagation of waves travel faster, perpendicularly to a wavefront. Reflection occurs within the same angle as the incident ray. Refraction occurs within the two boundaries of media, thus making a new medium and be refracted. Diffraction shows that each point on a spherical wavefront can be considered as a source of a secondary wavefront. Interference occurs when two waves meet while traveling along the same medium to form a resultant wave of greater, lower, or the same amplitude. Lastly, the line of sight propagation travels in a direct path and cannot travel over horizons, obstacles. Ground wave propagation occurs at the Earth's surface and the ionosphere that can reach up to 2 MHz. Skywave propagation are used by broadcasting and telecommunication. It transmits that can be received by many. So that is all for today. And these are my references used over the course of the lesson. Thank you and God bless.